Hello. 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 Hello.
Hello.
Hello. Hello. Can you hear me? Okay. Okay. Thanks. Okay. Let us start our first meeting. So, hello everyone. I am Bittu Singh. So, I'll try to guide you, and if you have any doubts, please feel free to ask. So, here I will solve some problems, and you can stop me anytime if you have any doubts or any question. So, let us start. So, first problem says every system of linear equation has a solution. So, is it true? It is true or false? What will be the answer? So let us take an example. So suppose the system is like this. Suppose x plus y is, or let us take an easier way. So suppose x equal to 1 and x equal to 0 simultaneously. So is there any solution? So suppose this is the linear equation. The answer is no. There is no solution. Because you cannot find any real number or anything which satisfy, which is equal to 1 and which equal to 0 simultaneously. It is not possible. So this system has no solution. Okay, so note that every linear equation may not have any solution, may not have a solution. So let us see this question. So suppose okay, for now let us consider the question. The question here, suppose the question is find the row echelon form or row reduced echelon form, whatever. So how do you find row echelon form? How do you find? So you have to reduce the matrix. The given matrix is A. So how can we reduce? The way for reducing is like this. So you can scale any row, scale a row, or you can exchange a row, exchange any two row, and the third way is multiply some row and add with another row. It is, suppose this row with R1 and this row is R2. We can do like this: R1 plus some constant into R2, or R2 plus some constant into R3. So those are the three ways for row reduction. Hello? Hello?
Hello.
Yes, yes. Hello? Okay. So here we need to reduce the matrix. So what is the way? The way is to row echelon form. For this matrix, it will be like this: first non-zero entry of a row, it should be 1. Okay, so how will you get 1 for A? You can see that first non-zero entry, it is 5, it is not 1. So what is the way to get 1? Clearly we need to do this operation: 1 by 5 times R1. Okay, so then it will becomes 100, 150 and 015. Now, so since leading entry or pivot, whatever, since pivot contains 1, so other for this column, other row cannot contain any non-zero element. You can see that second row contain a non-zero element. If you see this column, the second row contain a non-zero element. So you have to remove this one. So how can we do this? So the way is R2, that is third operation. We will use this third operation. Okay, this third operation. So R2 minus first row. So R2 minus R1. Now this will become 1 0 0 0 5 0, and now the third column is 0 1 5. Now again the leading entry in the second column is 5, so you have to reduce this entry. So how can we do that? Again we'll use this operation, scale a row. So what is the scaling factor for this? Multiply the second row with 1 by 5. Okay, so now it will becomes 1 0 0 0 1 0 0 1 5. Again you can see that since the second column contains leading entry 1, so other element in this column must be 0. It is 0, but you can see that this element is non-zero. So you have to somehow get 0 here. Okay, so what is the way? Again use this operation. Okay, multiply some row and add or subtract, or multiply with some constant and add with this row. So R2 minus 1 times R2. Sorry. Now this matrix will become 0 1 0 and 0 0 5. Okay, so it is almost done, but here again you can see that leading entry of the third row, it is 5. So what is the way? The way is to multiply the third row with 1/5. Okay, 1/5 times third row, then it will becomes 1 0 0 0 1 0 and 0 0 1. So you can see this is the identity matrix, and therefore the row echelon forms of the matrix A, it is the identity matrix 1 0 0 0 1 0 and 0 0 1. Is there any doubt? Okay, then there is another question for this. So the main question is to find a scalar such that ax equal to some constant into x. Find the scalar c. Find a scalar c for which ax equal to cx. Okay. Sorry. This is the question. So let us try to solve this. Again, what was A? A is that matrix This is the matrix A. So you have to find a scalar x, find a scalar c, find c such that ax equal to cx. Okay. So c is a scalar. C belongs to R, real number. And what is x? X is the column matrix, something like this: x1, x2, x3. You need to find this x such that this uh, equation satisfies. Okay. So let us try to solve. So here, what is ax? 500 150 015. And what is x? X is x1, x2, x3. This equal to c times x. X means again x1, x2, x3. So therefore this will imply what you can do. So the ways multiply here. So it will give cx1, cx2 and cx3. And multiplying left hand side, what will get? Recall how the matrix multiplication works: row times column. Okay. Then first row, this times column, this will give 5 times x1, 0 times x2, 0 times x3. Therefore it will be 5 times x1, because 0 times x2 and 0 times x3, it gets cancelled. So what will be the second row? It will be x1 plus 5x2 and 0. What will be the third row? Third row will be x2 plus 5x3. So this is same as cx1, cx2, cx3. Now taking the left hand side, what we'll get? This minus this equal to 0 matrix. Okay. So now it is same as 5 times x1 minus cx1. That is 5 minus c times x1. And the second one is x1 minus cx2 plus, sorry, x1 minus cx2 plus 5. So it will be 5 minus cx2. Then what is this? It is plus x2, 5 minus cx3. This is same as 0, 0, 0. You need to solve this equation. So comparing each row, what will we get? We get 5 minus cx1. This is 0. And okay, and x1 plus 5 minus cx2, this is 0. And another thing is x2 plus 5 minus cx3, this is again 0. Okay. The question is not like this: find c such that x equal to cx. Find c belongs to R such that x equal to cx. satisfies this satisfied by for non-zero x. Okay, because when x is 0, there is nothing to solve, because you take any real number 0 when x is 0 itself. When x is 0, then what is x? X is 0. So c times x, it's satisfied by any c. So there is it is not interesting. Therefore, we take the question is like this: for some non-zero x, it has solution. Now there is a trick. You can you have familiar with this trick, that a system, recall this, a system ax equal to 0, when this system has a non-zero solution. Can anyone say?
When it is invertible?
Yes. When it is invertible, this implies a inverse ax equal to 0. Therefore, x equal to 0. So then x has only one solution, which is trivial solution. But if a is not invertible, this system has a non-zero solution. Okay. So now this system can be written in this way. You can write this system as 5 minus c, 0 0 1 5 minus c, 0 0 1 5 minus c times x. What is x? X means x1 x2 x3. Okay, this is same as 0. That is, this is a, this is x, and right hand side is 0. So you have to find the determinant of this thing. That is, when a is not invertible. What is the meaning of not invertible? When a matrix is not invertible, what is the condition?
If C is equal to 5, then it is not invertible.
Yes, yes, it is right. What you have said, it is right. So the condition for non-invertibility is determinant equal to 0. Okay, a is not invertible. This is same as determinant of a is 0 for a square matrix. Okay. For here, you can see determinant of the matrix A. It is same as 5 minus c times 5 minus c times 5 minus c. Okay, which is 5 minus c whole cube. And so this determinant should be 0. Therefore, c equal to 5. Okay, is it clear? Hello. Okay, please. I think there is no doubt for this question. So let us move to another question. So here we need to solve this system of equation. There are 3 equations and we need to solve this. So what is the way? The way is,
Can we record this so we can see later on?
yes, please record. Okay. So we can write this system in this way. The system can be written as a times x equal to some b, at b.
Actually, I don't have recording permission. You cannot
Okay.
be admin.
Yes, I am recording and I will upload this to YouTube. Okay.
Thank you.
Okay. So here b is -2, 7 and -3. What is a? You can see the a is given by this coefficient of x1, x2, x3. That is, you can write a in this way: 2 -2 -3, 3 -3, and 5. Sorry. There are another thing: 3 -3 -2 and 5x4. So it is 5, and there was no x4 entry, so it is 0 times x4. And for third equation, we'll get third row, which is 1 -1 -2 -1. So this is a, and what is x? Here x is this x1, x2, x3, and x4. Okay. If you multiply this matrix A with x, you will get this equation. That is, this matrix equal to this matrix. Okay. That is, the whole equation can be written, can be represented by a single equation. So let us see what is happening here. So we need to solve this equation. Solving a equation, the linear algebra deals with solving linear equation. You can see this equation is linear. Why? Because x1, x2, x3, those unknowns or those variables, this is their degree is 1. That is, there is no x1 square, x1 cube, or their product. There is nothing like this. Everything is linear. This degree 1 term, and linear, or there might be some constant term also. That is -2, -7, and 3. Those are constant. So the ways like this: put a and this b into a single matrix. That is, write like this: a and b. So you can write in this way: 2 -2 -3 0, and -2 7 -3 3 -3 -2 5 1 -1 -2 again -1. We have written in this way. Okay, this matrix is called augmented matrix. Remember this. This matrix is called augmented matrix. So how can we solve this? Simply use row reduction. Okay. By using row reduction, we can solve the system. Solve the system. The system was ax equal to b. So what is the steps of row reduction? someone, please. The step 1 is to
interchange R1 and R3.
okay, yes, you can interchange rows. Great. So 1 R1 and R2 node, we will interchange R1 and R3, okay? Because we want first non-zero entry to be 1. That is pivot or whatever leading entry, it should be 1. So we'll interchange R1 and R3. Or you can just multiply this with half. Okay, there are many ways to reduce. So first we will interchange R1 R3. So then this will becomes 1 minus 1 minus 2 again minus 1 and there will be minus 3. And what is R3? Now R3 is 2 minus 3 and 0. And this is minus 2, so here it will be minus 2. And middle row, it is not affected by this operation. So middle row remain fixed. 3 minus 2, 5. Here it is 7. So what will be the next step? What is the next step?
R2 minus 3 times R1.
Okay. Yes. So since leading entry is 1 and no other entries in this column, for example 3 and 2, this should be 0. Okay, so what is the way? R2 minus 3 times R1. Okay, so apply this R2 minus 3 times R1. This will give 1 minus 1 minus 2 minus 1, and here it is minus 3 and it is 0 now. Again you can see 3 minus 3, it is 0. Now minus 3 minus 3, then it is also 0. Okay, so it is also 0. Now minus 2, the second thing, third thing will be minus 2 minus 3 times minus 2. What is this? What is this? It is 4. So it will be 4. And after that it is 5 minus, this entry will be 5 minus 3 times minus 1. That is, it is 8.
8.
Yes. So, and after that, what is this? 7 plus 9.
16.
Great. So R2 minus 3 1, 3 into R1, and by the same way we can do R3 minus 2 R1, because we need to remove this 2 also, because we need to, there should be 0. As we know, in row reduced form or row echelon form, the column which contains a leading entry, other things should be 0. Therefore, we need to perform another row operation, which is R3 minus 2 times R1. Okay, then this will get 0, and after that minus 2, again minus 2 plus 2, so it is 0 again. And what is after that? Note, it is
1.
yes, this is 1, so there will be 1. And what will be after that? It is
2.
yes, great, it is 2.
Next one is 4.
Next one is 4. So those are the rough steps. Now again, what will be the next step?
1 by 4 into R2.
Yes, 1 by 4 into R2. Because the first non-zero entry of the second row is 4. This 4, we have to perform a row operation such that this 4 becomes 1. Because first non-zero entry should be 1 for row reduced form. Therefore, what can we do? Just multiply the first thing and the second row with 1/4. It is first row becomes same, but the second row it is 0 0 1 2, and now 1/4 of the second row, that is 4. Again 0 0 1 2 4. Now what is the operation? Row operation again.
R3 minus R2.
Yes, R3 minus R2. Because by the same reason, because this column contain a non-zero a leading entry 1, so other non-zero entries should get cancelled. Okay, so we need to perform R3 minus R2, and simultaneously or by another step we need to perform this thing also, R1 plus 2 R2, to cancel this element. We need to cancel those two things. Okay, so it will be 1 minus 1 0, multiply 2 with this and add, that is 3. Again, what is this? It is 8 minus 3, that is 5. 0 0 1 2, this 4, it remains fixed, and after that it will be 0 0 0 0 and 0, because R3 and R2 are the same rows, that is those rows contain same element, so subtracting this will gives 0. So is it done? Yes, the steps are over. So now we can solve. So the whole system, this and the new system, these are the same. So solving the first system and solving this system will give the same solutions. Okay, so solving the reduced system will give the same solution. So what is the new system? Here you can write it as Rx, this is R, and this is B dash. So the new system will be Rx into B. Rx equal to B. Okay. So what is this? So multiply R. R means 1 minus 1, 0 3, 0 0 1 2, 0 0 0 0 times x. X means x1, x2, x3 and x4, because there are four variable involved. This is same as b dash. Okay, b dash means 540. So this is equivalent to, if we multiply, this will gives x1 minus x2 plus 3x3 plus 3x4, sorry, this is equal to 4, and x1, sorry, there will be x3 plus 2x4, This is 4. So now it becomes more easier to solve this. Okay. So what is the way? You can set export anything. So let export is t, where t is a real number. Okay. Then if we denote export equal to 4, then the second equation gives x3 equal to 4 minus 2x4. That is 4 minus 2t. Okay. And now from the first equation, what will we get? So since there are only two equations now, we need to set two variables. There will be two free variables. Okay. One variable is x4 and another, you can set x2 is another thing. That is, you can set x2 equal to another real number s. Okay. So then x1 is 5 plus x2 minus 3x4. That is 5 plus x2 is same as s minus 3x4, and x4 is t. Okay. Therefore, the solution will be, what will be the solution? X1 is 5 plus s minus 3t. X2 is s. X3 is 4 minus 2t. And x4 is t, where s comma t is any real number. Okay. For example, choose s and t both are 0. Then if we choose s comma t both are 0, 0, 0. Okay. Then what will we get? We'll get the solution will be like this. X1 is now 5, x2 is 0, x3 is 4, x4 is 0. So let us see this 5, 0, 4, 0 satisfies the equation. If it satisfies, so x1 is 5. What we have seen, x1 is 5 and x4 is 4. So put 5 and x2 is 4. Sorry. What is
Not
this?
x2, x3 is 4.
X3 is 4. Okay. So 5 times 2, it is 10, and 4 times 3, it is 12. So what is 10 minus 12? This is same as minus 2. Okay. Again, 5 times 3, it is 15, and 4 times minus 2, it is 8. So 15 minus 8, it will give 7. Therefore, clearly you can see this is a solution 5040, because this thing satisfies all the three equations. Okay. So this is a solution, and instead of choosing st both are 0, 0, choose any other thing. For example, choose s equal to 1, t equal to some 2, or any real number, whatever you want. You can you just put those entries in the equations. You will get you will see that the system. Okay. Is there any question? Okay. So this is how you can solve a system. And let us see another question. So here the question is to multiply A times B times C and C times A times B. So is matrix multiplication commutative?
No.
No.
No. So the expectation will be ABC and CAB. Those are different, or it may be same also, because for a particular case it can be same. Okay. So let us see what is happening here. So first multiply A times B. What is A? A is 2 minus 1 and 1. 1, 2, 1. And B is 3, 1 minus 1. So what is the way of multiplication? Row times column. Okay. That is 2 times 3 plus minus 1 times 1 plus 1 times minus 1. The next row is 1 times 3 plus 2 times 1 plus 1 times minus 1. Okay. So what is this? This is 6 minus 1, 5, and another minus 1, that is 4. And the second thing is 3 times plus 2, 5, 4. So now AB times C. C is 1, 1 and minus 1 row. 4, 4, 1, minus 1. What is this? So now this row is 4 and this column is 1. So it will be 4. Similarly, 4 times minus 1, this is minus 4. Again, this column is 4 times 1, 4 minus 4. Now we need another thing, C times A times B. C times AB. C is 1 comma minus 1. 4, 4. What is this? What will you get? 1 minus 1 times this, that is 1 times 4 plus minus 1 times 4. That is same as the 0. So you can see that you cannot compare those two matrices because their order are different. ABC is 2 by 2 matrix, but CAB it is 1 by 1 matrix. So they cannot be equal. And our guess is right. That is ABC and CAB, that is matrix multiplication is not commutative. If it is commutative, then AB times C and C times AB, those two things will be equal. But you can see that it is not equal. Okay. So this is the answer. There is another question. Here we need to find the inverse of this matrix A. Okay. A is 1, 2, 3, 5. So what is the way? You probably know this formula. There is a formula for finding inverse. The formula says if A inverse exists, then A inverse is uh, adjoint A by det A. Okay, you need to find adjoint, then divide this by determinant. Okay, so here you can see that determinant of this matrix A, it is 1 times 5 minus 2 times 3. That is same as minus 1, which is not equal to 0. It is not equal to 0. Therefore, this A inverse should exist because determinant is non-zero. Okay. So this is a formula to get inverse, but the problem is, though this formula works nicely for small matrices, for example 2 by 2 or 3 by 3 matrices, but if you are given a big matrix, then this formula, it is laborious to use this formula. Okay, so we'll use another thing. The known thing is row reduction. So using row reduction. So simply write this matrix. Again, this matrix A I. I is the identity matrix. Okay. So what is this? 1, 2, 3, 5, and the identity matrix is 1, 0, 0, 1. Now you can do row reductions. Okay. So what is the first step of the reduction? Someone? Simply R2 minus 3 R1. Why? Because we want to cancel these 3. Leading entry is 1, so any other thing in this column should be 0. Okay, so we perform this R2 minus 3 R1. So this will gives 1, 2, 1, 0, then 3 minus 3, that is 0, 5 minus 6, that is minus 1, and after that it will be minus 3, 1. What will be the next step?
A2221.
What?
Minus R2.
Yes. Yes. So we want, that is, leading entry should be plus 1. That is, we need to multiply this thing with minus 1, or 2 times minus 1. Okay. So this will gives 1, 2, 1, 0, 0, 1, 3, minus 1. And now again we need to cancel this thing.
R1 minus 2 R2.
Yes, exactly. So R1 minus 2 R2, this will gives 1, 0, and 1 minus 6, which is same as minus 5, and 2. Okay, great. And this thing is same as 0, 1, 3,
Minus 1.
minus 1. Okay. I have done some mistake because this is not the way to get inverse.
It is just adjoint here. So it is correct.
Yes.
A inverse is adjoint here by delta.
Yes. Okay, so inverse should be inverse A inverse. That is, this is actually, this matrix is the same as I, identity matrix, and this thing is A inverse. Therefore, A inverse is same as the second thing, minus 5, 2, 3, and minus 1. Okay. So you can simply multiply 1, 2, 3, 5 with this. Let us see what is happening. 1, 2, 3, 5 into minus 5, 2, 3, minus 1. Here it is done actually. So this is same as 1 2 times, it is minus 5 plus 6, which is 1. 2 minus 2, that is 0. Minus 15 plus 15, again 0. 6 minus 5, this is 1. That is A times A inverse is identity. Therefore it is correct answer. Okay, A inverse is this. So is there any doubt? Abhijit, is there any doubt?
No, sir.
Okay, those are the things. Let us see some problems. So two matrices are given. Okay, one matrix is 1 0 minus 0 0 0 1 minus 1 0 0 0 1 0. The question is it row reduced? Is it row reduced? If not, why it is not row reduced? Can someone tell?
Let
No,
us
it is not row reduced.
Yes, Mrinal, it is right. But why it is not row reduced? Why is it?
It is in the third column. Last element is 1.
Yes.
It should be 0.
In the third column, last element is 1. No,
It should be 0.
this is not the correct reason.
actually this minus 1 should be 0.
Second row and third column, the entry is -1.
Yes. Here, the entries is -1. We have to remove this thing. Okay. So we need to perform another operation. No, it is not. So we need to perform another operation. So what will be the operation?
R2 is R2 plus R3.
Yes, R2 plus R3. Multiply the third row with 1 and add with R2. This will gives 1 0 0 0 0 1 0 0 0 0 1 0. Okay. So there is another example which is 0 to 1 1 0 minus 3 0 0 0. Now what is the problem?
Leading term in first row must be non-zero.
Yes, leading term should be 1. Leading terms should be 1.
Yeah.
Here it is 2. So what will be the operation? What do we need to perform?
R2 interchange with R1.
Okay. R2 interchange with R1. Yes, it is the right way. This will give 1 0 minus 3 0 to 1 0 0 0. But is it row reduced?
No.
So what do we need to perform?
First, we have to make in R2, A22 should be 1.
Yes, a to 2 should be 1. So
So
what we
R2
should,
multiply by 1 by 2.
yes, correct. R2 multiplied by 1 by 2. And this will give 1 0 minus 3, 0 1 and half, 0 0 0. This is row reduced. And even you can say more, because this is not only row reduced, eh, you can say this is in echelon form. Okay, for echelon form, these leading entries should follow a pattern, that is, leading entries shift to the right. Okay, for example, even if it is 1, sorry, even it is even if it is 1, it is not a row echelon form. Okay, why? Because for echelon form, this leading entry should follow a pattern, that is, the next rows should not contain some leading entry before this. Okay, it should be after 1. For example, here this one can be present there or after this, anyhow. Okay, so this is row reduced, and it is also in echelon form. So let us see some more problems. Okay, the question says x1 plus 2x2 equal to 0, and 2x1 plus 4x2 equal to 0. So find all the solutions. How can we solve this? Again,
It has infinitely many solutions.
yes, there will be infinitely many solutions. Why?
Because both equations are same.
Yes, because both the equations are same. Actually, second equation, you can see this is nothing but multiply first equation with 2, then you will get second equation. So there are only one independent equation. Hmm. The equation is 1 plus x1 plus 2x2 is same as 0. Okay, and therefore there is one free variable. The free variable is x2. So set x2 equal to t. Then what will you get?
X1 is minus of t.
Minus of
2t.
2t. Yes. So the solution can be given in this way. Therefore, solutions are given by x1 equal to 2t. Sorry, x1 is t, and x1 is minus 2t, and x2 is t, where t is any real number. Okay. For example, put t is 0. You will get x1 is 0 and x2 is also 0. So you can see this satisfies the equation star, because 0 plus 2 times 0, it is 0. For example, set t is 2, then what will you get? X1 is minus 4 and X2 is plus 2. Then again put X1 and X2 here. You will get minus 4 plus 4. But minus 4 plus 4 means 0. So if this single equation gives all the solutions, because you cannot write t equal to 0, t equal to 2, or t equal to minus 1.5. You cannot write everything by single thing, but if you put t here, everything can be given by this single solution. So this is the way. Let us see other questions. So here it is given like this. A is I minus 1 plus I, and 0, it is actually I, okay, and 1 minus 2, 1, 1, 2I, and minus 1. The question is find row reduced form. Okay, row reduced form of this matrix. So what will be the row reduced form? So the first step, what will be the first step?
R12.
R1 and R2 exchange, okay? Yes. So exchanging this thing, it will gives 1
minus 2, 1,
yes,
iota, minus of 1 plus iota,
yes,
0, 1, 2 iota minus 1.
right. Then what will be the next step?
R2 change with R2 minus iota R1.
Yes, iota times R1, and also the third row also contain 1, because
Yes.
yes, what will
R3
be,
minus R1.
yes, R3 minus R1. So this will gives 1 minus 2 1. This will
0.
0, and
And this way then
minus 2i, that is plus 2i,
minus 1, minus
Plus I.
plus I, yes. And here it will be minus I. After that,
Minus I.
it is again 0.
twice of I minus I plus 1
Yes. So it is, sorry,
and minus 2.
2. And
I plus 1.
yes,
Iota plus 1.
2 plus 2y, because
Yeah.
minus of minus 2.
Twice of I told.
Here, after that, it is minus 2, no?
Minus 2.
Okay, good. So what will be the next step? Next step, what is the
R2 change to R2 minus half of R3.
R2 minus,
No.
R2 tends to R2 minus R3 upon 2 into I plus 1.
but you just simply, you can see that leading entry is minus 1 plus I.
Yeah.
So you can multiply this thing with 1 plus minus 1 plus I, inverse of this. Okay. Uh, okay. So what is minus 1 plus I inverse? Inverse of minus 1 plus I. What is this?
minus 1
minus
minus
one, minus 1 minus I upon minus 2.
minus 2.
Minus 2. Yes. A minus, because A plus IB inverse, this is same as A minus IB by modulus of this, that is A square plus B square. So, or in other words, Z bar by mod Z square. That is same as half of 1 plus I. That is just multiply, instead of this inverse, it is same as multiplying with half of 1 plus I. Okay. So this will give 1 minus 2 1 0 1. Now minus I times half of 1 plus I. What will be this? Minus I. That is
1 by 2 into minus 1 plus 1
yes, minus I
plus 1.
plus 1. Because I times
Excuse me,
I
1
square.
minute. Hello.
So inversely
A
minus
square
1.
plus B square is always positive, but it is not minus 2 because A, B
So
are any
inverse
real
में
numbers.
negative आएगा sign.
Yes, sorry. I'm sorry.
Positive 2, yes sir.
It is, sorry. Thanks. So it will be 1 and there will be a negative sign. Okay, so it is actually minus 1 plus I. I think now this is correct. Okay, I square minus I, because there will be minus of this, minus of half times 1 plus I. Okay, sorry. What will be the next step? This is same as 0, 2 plus 2I and minus 2. What will be the next step?
R1 plus 2 R2.
Yes, R1 plus 2 R2 and
R3 minus 2 into R2. 2 into I plus 1 into R2.
yes, minus 2 plus 2I into R2. Okay. Okay. So this will give 1, and after that it is 0, and 1, that is 1 plus 2 times R2. What is this? It is I, because 1 plus minus 1 plus I, this is same as I, and it is now 0 1 half of minus 1 plus I. After that it will be 0. Now this term will get cancelled, and after that it will be minus 2. So let us, we have got minus 2 plus 2I times half of minus 1 plus I. This is same as 1 plus I into minus 1 plus I. That is
Minus 2.
is, what will be this? 1 plus I into minus 1 plus I. That is same as minus 2. Okay. This is 0 actually.
0.
Yes. So this is the required row reduced form. Okay, let us give the name R. R is the required row reduced echelon form, moreover.
Row echelon form.
Yes. Uh, Now, so if uh, you are you familiar with vector spaces? Or let us not do. Okay. Question number 6 in my book. Uh, there is a problem. It says x1 minus 2x2 plus x3 plus 2x4. This is same as 1. x1 plus x2 minus x3 plus x4. This is same as 2. And x1 plus 7x2 minus 5x3 minus x4. This is same as 3. So the question says, what is the solution? If exist, what is the solution? We don't know solution exists or not. If exist, what is the solution?
Infinite solution.
Infinite solution. Uh, if
Number of variable is greater than number of iteration.
but do you are you sure that solution exists? Are you sure about that? How do we know that solution exists or not?
Okay.
Okay. So let us try to perform. So here is
Argumented matrix we will
yes.
check.
So this is Ax equal to B.
B.
So this augmented matrix, that is AB, and the given matrix, which is A. Those two matrix have same rank. This is the condition for existence of
Solution.
solution. If solution exists, yes, you are right. Then there will be
Solution
infinite
does
limit.
not exist.
Okay. Why? How can you say that solution does not exist?
The rank of A is not equal to the rank of augmented matrix.
Okay. Okay. Yes, it is true. So let us see that you are right. Let us see if the rank. So what is augmented matrix here? It is 1 minus 2.
1 minus 2, 1, 2, 1, 1, 1, minus 1, 1, 1, 7, minus 5, minus 1.
This is A is to B. So we'll perform row operation. Okay. So what will be the first step?
R2 minus R1, R3 minus R1.
Yes, great. 3 minus 1. So this will give 1 minus 2, 1, 2, 1, 0,
0, 3,
3,
minus 2,
minus 2,
minus 1,
minus 1, 1,
and 1. 0,
0,
9, minus 6,
minus 6,
minus 3,
minus 3,
2.
2. Right. Now what will be the next step?
R2 by 2, 3.
Yes, R2 by 3, but let us not do this operation because we don't want to get
Okay, okay, fractional.
okay.
R3 minus 3 R2.
Yeah.
Then 1 minus 2, 1, 2, 1, 0, 3, minus 2, minus 1, 1. And after that, it will be 0, 0, 0, 0,
Minus
Okay.
not equal to 0 last one.
minus 1.
Minus 1.
2 minus 1.
Now you can see that rank of A, what can you say from this?
Rank of A is 2 and rank of argument matrix is 3.
Yes.
Yes, rank of A is 2, but rank of the augmented matrix
Is 3.
is 3,
So no
which is
solution.
not equal. Okay. Therefore,
Solution does not exist.
yes, the system has no solution. Let us try to solve some more problems. Okay. Okay, there is a interesting question. There is an interesting question which says, given A is 1 minus 1, 2, 2, 1, 0, and B is same as 3, 1, minus 4, 4. So the question is there any matrix C such that C times A is same as B? So you need to find if there exists some matrix C, you need to find that matrix. So what will be the order of the matrix? Order of C, what will be the order?
2 by 3.
2 by 3. Why?
Because B is 2 by 2, so 3 by 3, 2 by 3 into 3 by 2 is 2 by 2.
Yes, 2 by 3 times 3 by 2
It's 2 by
matrix.
2.
This multiplication will give 2 by 2
2
matrix.
by 2 matrix.
Exactly. So C is 2 by 3 matrix. So uh, just assume C is like this: x1, x2,
X1, X2, X3, X4.
and another row you may assume x4, x5, x6, whatever. Okay. So C times A. What will be C times A?
X1 plus 2x2 plus x3
Yes. Plus x3
then
and
next
minus x1
plus 2x2
to x2 and 0. After that,
x4 plus 2x5 plus x6
yes,
minus x4 plus x plus 2x5
this is same as 3.
3 1 minus 4 4 plus 4.
So you can see the there are two sets of equation. Okay, so the first set is x1 plus 2x2
Plus
plus
x3
x3.
is
This
3.
is 3 and minus x1 plus 2x2.
So my 1.
This is 1. And another set is same as
x4
x4
plus 2x5
2x5
plus x6
x6. This is
minus 4
4 minus 4.
minus x4 plus 2x5 is 4.
Right. So here you can do row operation, but without the involving row operation, can we do that? So let us do a row operation. For example, for the first question, we can use this operation. It is 1, 2, 1, 3,
3
1.
minus 1 2 0 1.
Then what will be the operation?
R2 R1 plus R2 R2 plus R1.
1, 2, 1, 3, 0, 4,
4
1.
1 4.
So we are not getting something easier. So after that, simply half of R2. 1, 2, 1, 3, 0, sorry, 1, 4.
1 4.
Sir, it is
1.
not required.
Yes.
Sir, it is not required to eliminate.
Yes, yes, I am recording. I will upload this video to YouTube. I'll share the link.
Sir, no. This last step not required to solve. No.
Oh yeah, this step is not required. Even actually, we don't need to reduce for that. Yes, yes, you are right. So therefore, we have again two system: x1 plus 2x2 plus x3. This is 3, and x2
Minus x2.
x2 plus x by 4. This is 1.
Equal to 1. Yes.
Okay, this is the reduced equation. Reduced equation corresponding to this one. Okay, reduced equation corresponding to for 1. So you can see that this third there is nothing. So pivot are in the first column and in the second column. So third column there is no pivot. So you can choose the third entry anything. So sorry, it is 2 and it is x3 by 4.
3 by
X3.
4.
So choose the third entry x3 to be t, where t is any real number. Okay. And then what will be x2? x2 is 1 minus
Minus t by 4.
T by 4.
4. Yes. And what will be x1? 3 minus 2x2 minus x3, which is same as 3 minus
Minus
2 times 1 minus t by 4 minus x3
3.
minus t. Yes. So 3 minus 2, that is 1,
1.
and
Minus 3 by 2. T.
minus t by 2. Yes. Therefore, for first
3
one,
by 2.
it is plus t by 2 minus t, which is minus t by 2.
Yes.
So we have figured out what is x1, x2, x3. In the same way, you have to solve for this. Okay.
Okay.
Solve for x4, x5, x6. and you will get all the values. For example, without doing those operations, you can easily get for those type of cases, because here you can see that you can write x4 is same as 4 minus 2x 2x5 minus 4. Okay.
minus 2x5.
नहीं ठीक है.
Yes, it is correct. And similarly, so set x5 is s. Okay. By the same reason, set a variable to be free. That is, s is any real number. Then x4 is same as 2s minus 4. And what will be
x6
x6
minus 4
minus 4 minus x4
minus
minus 2x5.
5
So what is this?
minus 4
Minus 4 minus
minus 2s plus 4
yes, 2s
plus 4
plus 4
minus 2s
minus 2s. That is same as
4s minus 4s.
minus 4s. So you get the solution will be of this form. So what is this? Just copy this. Okay. What was that? It is same as minus 2s, no? Minus 4, sorry. So solution can be given in this way. S5 is s. So therefore the solution is, what will be the matrix?
1 minus t by 2.
Yes. C is x1, x2, x3. 1 minus t by 2.
1
1 minus 3 by
minus
4
t by 4.
1
T.
minus t by 4. T.
t
T.
And then x4, x5, x6. That is
2s minus 4
2s minus 4.
s
S.
s
minus 4s.
minus 4s.
So any C will work for that is for any
t and s belongs to.
ST belongs to the real number R. Okay. If the field is not stated, just assume the field is a real number. If it is, you can see that there is some iota or some complex entry, then you should consider the field to be a complex field. C. And if nothing is there, you just assume the field to be a real field. Okay. Real number, that is entries are from real number. That's why we have assumed str from real. Okay. So let us try to solve another question. Even A is 2 cross 1 matrix. Okay. That is 2 by 1 matrix. And B is 1 by 2 matrix. And also C is A times B. So the question is, prove that C is not invertible. Prove this. So just take A to be 2 by 1 matrix. That is choose, suppose this is A times A and B, and B is 1 by 2 matrix, that is one row. So C, D. A, B, C, D are from real, A, B, C, D are any real number. So what is C? C is A times B. What is A times B? What is A times B?
AC, AD,
AC,
BC, BD.
BCBT, right. Now, now what can you say?
Determinant is 0.
Determinant of C is 0
Therefore, it is not invertible.
because it is AC times BD minus AD times BC, which is 0. Therefore, it is not invertible. C is not invertible. Okay.
Sir, question number 2 from assignment.
Question number 2 from assignment,
One.
but assignment we cannot discuss. What was the question?
It is A is a matrix. Aij is smaller than K.
A is a matrix,
N by N matrix. N by N.
N by N matrix.
And can you see, because there is some notation which I don't know, like if you can
Okay,
see.
okay. Let me see this. What is the question number? Question number 2, na?
Yes.
Entries are less equal to K. K is positive integer. Then what is the determinant? Determinant of A. Okay.
No, it is saying that yes. What is the question? Like the first line, which says Aij is smaller than K.
Yes.
What is this? Is determinant of the matrix A, or
No. Aij means you can write A as entryway. In A as this Aij. Where Aij means entries of the matrix.
okay, coefficients? So
Coefficient.
So it means each entry must be less than K.
just a second. So does it mean that each coefficient in the matrix is smaller than equal to K, right?
Modulus of each coefficient. That
Oh,
is
modulus.
yes.
Okay. So in the answer also, this vertical lines are modulus.
Yes, yes. In the end.
Okay.
Yes.
Okay. Okay.
Okay.
Thank you. So if you can discuss a little bit how to approach this question, just even if you give hint, it is okay.
Okay, okay. Yes. Let me give hint for this question. So, do you know what is the formula for determinant? How can you find determinant? So, determinant can be, it is just sum of the permutation, and there will be it is A1 sigma 1 up to AN sigma n. Okay, sigma belongs to permutations. sigma belongs to permutation. So sorry, there will be sign of sigma.
What is this notation? I'm not aware of this.
Okay. So what is sigma? Sigma is a permutation. Permutation means, for example, you can write 1, 2 up to n. This is a permutation. Okay. Permutation means it is a map from n object to n object. Permutation means bijection from n object to n object. For example, here, this sigma 1 denotes this map 1, 2 up to n, and send 1 to 2, send 2 to 3, and up to n minus 1, send n minus 1 to n, and after that send n to 1. That is, this is actually cycle notation for the permutation. Okay.
Yes, sir. Yes, sir.
That is, 1 goes to 2, 2 goes to 3, 3 goes to 4, and after that n minus 1 goes to n. But where n goes?
N goes to 1.
N goes to again the first thing 1. For example, take another sigma 2. Sigma 2 means, suppose 1, 2 up to 4, and after that 4, 5 up to n. What is the meaning of sigma 2?
Sigma 2 means 1 km is 2, and 2 km is 3, 3 km is 4, and 4 km is 1.
Here 1 goes to 2, 2 goes to 3, 3 goes to 4, and 4 goes to 1.
Yes.
But what is the step after that? That is, now, sorry, there will be no 4 again, because 4 is already consumed. So now 5 goes to 6, 6 goes to 7, and after up to n minus 1 goes to n, and then
N goes to 5.
goes to 5. This is how we denote permutations. Permutations mean actually bijection between n object. Okay, and this is standard notation for permutation. Notations. Cycle notation.
Uh, I am not okay, this is the formula. Say if we start from basic matrix, how can I understand this sigma 1 permutation? Say if I take just 2 by 2 matrix,
Yes, yes. So
how,
let us write 2 by 2 matrix. For example, 2 by 2 matrix means A11. Example. It is A11, A12, A21, and A22. This is actually A. So what is the determinant? What will be determinant?
yeah,
A11,
A1, A22 minus A12, A21.
A21. So here you can see, for example, here if we denote the second thing by sigma, okay, that is A1 sigma 1, A2 sigma 2. What is the value of sigma 1 and sigma 2? Sigma 1 is 1 and sigma 2 is 2.
2.
Okay, that is, this is actually identity permutation. Identity permutation. And again, if we write A1 times, suppose now we denote it by sigma dash 1, A2 sigma dash 2. Then what will be sigma dash?
1
Sigma
is
dash
2.
1 is 2, and sigma dash 2 is
2 is 1.
1.
1.
So the formula says we don't take sum of those n square many things. Okay, we need to take the sign of the permutations also. For example, for this identity permutation, sign is 1, and for this sigma dash permutation, which can be written as 1 comma 2, that is, sorry, 1 not comma, sigma dash is same as 1 2, and sigma is same as identity. Okay, so for sigma dash, it means 1 goes to 2 and 2 goes to 1. This is the way of representing permutation. So in general, we do not have uh, those small formula or those easier formulas. Therefore, we need to use those permutation formula. That is, we permute in every possible way. Note here that A1, and after that there are only two ways, because what will be the bijection between, so what will be the bijection between two object. So
Actually, what is bijection? It's
bijection
not.
means it is 1 1 and 1 2 function. Okay, suppose there are two entries which is denoted by 1 and 2, then what will be the map from 1 and 2 to 1 and 2? For example, for a finite set, you can assume that bijection is a rearrangement of this set. Okay, that is, you can map 1 to 1 and 2 to 2.
Or
Other
1 to 2, 2 to 1.
Yes. So there are two factorial many ways.
So 2 to 1.
Sorry, 2 to 1. Now instead of 2, if there was 3 object, now how many ways you can map?
6.
6.
3
Six.
factorial.
Yes. Now 3 to 3, and similarly, that is, and this is the these are all permutations. Okay, so there are 6 way of permutation. Permutation is nothing but bijection
Bijection.
of n objects. That is bijection between n object to n object. Bijection of n object. So those are the all permutations. For example, if there are 3 by 3 matrices, you know there will be 9 entries, 6 entries. Okay, you write in this way. That is, for example, A1 sigma 1, A2 sigma 2, and A3 sigma 3. This is how we write determinant. That is, take product of all such ways and add sorry add with a sign of this permutation, sign of sigma. This gives determinant.
Okay.
Okay. So if you write this way, you will get the answer for this. The hint is use triangular.
But here there is something options have like k factorial, then n factorial, and also k.
Yes. So
So
that's why I am saying now you know that there are n factorials for n cross n matrix, there are n factorial ways of permutation. Okay, now use this thing. Okay, use this formula
Okay.
and use the triangle inequality. That is, triangle inequality says a1 plus a2. Suppose a11, a12. So this is less equal to,
Mod of A11 plus mod of A22.
yes. Use this with the formula. This is the formula you need to use. If you use this, you will get easily what will be the answer. Now let us solve few more problems.
One more question from the assignment.
Yes.
Question number 9.
Question number 9. Question number 9 says, for what values of C the system have a solution?
Yeah, actually, when I solved it, I found there are two answers, but here only one option I can choose.
Oh, what? Okay, you are not supposed to tell the answer. Um, for example, if you find the answer like this, C is 0, then C is already belongs to R. But you should choose C to be 0 because this is the most. This will be the better way.
No, R actually is is not for one value of C there is no solution. So that is why C belonging to R is not an option because one of them is not giving a solution. But two of them are giving a solution in the answer.
Oh, then it is a problematic thing.
Yeah.
Mhm. Okay. Then it is better to pick any one of them and send a mail to the authority. This will be the better way.
Okay. Hmm.
Okay. So let us try another problem. Up to now, is it clear, everyone?
Yes,
Is there
sir.
any question?
Yes, sir.
Okay, good. Okay. So mm, okay.
Hello, sir.
Yes, yes.
Can you recall the steps once again in this chapter? How to solve?
How to solve a problem?
Yes, sir.
Linear.
Not only in this, sir. Basically, in this chapter, what are all the steps we have to go?
Okay.
Yes, sir.
Then let us try to solve a problem again. Suppose consider these two equations, x1 minus x2 plus, or let us take the previous question. Yes. Well, yes, this is the question. The question is uh, how to solve this equation. Okay. Is it the question? Hello?
Yes, sir. Yes, sir.
Okay. So the step is to use the augmented matrix, that is, take the coefficient of x1, x2, x3, and x4, which is 2, 3, 1. Those are the coefficient, and write, and there is nothing, so we have taken 0. Okay. After that, it is minus 273. We have taken this. The next step is to apply row reduction. That is, you need to reduce the rows. Okay. So first step is we have exchanged this and this, and without exchanging, we can perform this half of R1 times 1 by 2. Okay. This is also a way, but it is better to exchange, because multiplying with something, you will get fractional terms. Okay. We always try to avoid fractional terms. That's why we have exchanged those two rows, and this will gives, this will becomes first row, and this becomes the second row, the third row. After that, again we have performed successive row operations. For example, adding multiples of some row, that is, multiple of first row, add this multiple with second row, or add multiple of first row with third row. Okay, so that other entries in the column which contains a leading term will be 0. Okay, this is what we are trying, and after several steps, it will becomes a row reduced form. Now, when you get row reduced form, it is almost done. So again, we will convert this into our form, that is 1 minus 1 times this, which is same as 5. We are comparing the entries, that is, this time this will get this will give x1 minus x2 plus 3x4, and this is same as 5. That is, this is same as 5, and similarly second row times this, which equal to x3 plus 2x4, which gives 4. Okay, so we'll get two equation, because the last row will give nothing, that is 0 equal to 0. You will get 0 equal to 0, which is not any precious information, so we just delete that thing. And the main thing is to remember that this new equation and the old equations have the same solutions. Okay, so here just note that pivot elements are in the first column and in the third column. First column contain a pivot which is 1, and the third column also contain a pivot which is 1. But you note that fourth and second column are free, because there are no pivot element. Okay, there are no leading term in second and fourth column. That's why set second column and fourth column to be any real number. We have taken second entry x2 to be s, and the fourth entry to be t, and putting those those thing in the given equations. For example, second equation is smaller, so we just put x4 is t in the second equation, and then you will get x3 to be 4 minus 2t. Similarly, now we put the value of x2 and x4. X2 is s, x4 is t. Put it here. Putting, you will get x1 to be 5 plus s minus 3t. Therefore, the solution can be written in a particular way, that is x1 to be 5 plus s minus 3t, x2 to be s, and x3 to be 4 minus 2t, and x4 to be t. So here s and t are free things. You can take any real number. This will work.
Sir, only one doubt, sir, here.
Yes, yes.
Why we are taking x4 as t and x2 as s, sir, here?
It is up to you. You can take anything. Not even st. You can choose anything, a, b, or anything.
Okay, why we are taking x4 and x2 here? Because they are the entries, right?
Yes.
Okay.
Why we have chosen x4 and x2, not any other thing, that is x1, x3? Is it the
Yes,
question?
sir. Yes, sir. Yes, sir.
Okay, because you note that what are the leading terms? That is leading non-zero entry. It is 1, and here is another 1. This
1
one
and 3.
1 is in the first column. This one in the third column.
Third column.
So second and fourth column will be free.
Free.
Okay, Bhuvana. Second and fourth column does not contain any leading term.
Yes.
That is the reason for picking x4 and x2. I think now it is clear.
Yes, sir. But your audio is breaking, sir. That's why I couldn't get you.
Oh, sorry. I am saying that second and fourth column does not
Yes,
contain
sir.
any leading term.
Yes.
This row contains leading term 1. This row
Yes.
contains leading term 1.
Yes, sir.
Okay, and this row has no leading term. Now
Yes.
note that this leading one are in first term and third column.
Okay.
Therefore, second and fourth column are free. You can
Yes.
choose anything here.
Okay, sir. Okay.
Okay.
Sir, I understand, but sir, I think there are two equation and there and 5 variables. So
Not
2
variable.
variables are required. No, sir. It is
Yes,
correct or
yes. That's why there will be two free things. That is, we have four variables and two equation. Therefore, two elements should be free. But the thing is, you cannot choose any two element to be free. Okay. Then there will be some trouble for some particular question. Here you can choose anything to be free. I think there will be no problem for this question. But for other question, you cannot choose anything to be ST.
Can you explain some other questions, sir?
I actually don't know for which question actually. Just I will say that you need to solve some problems to get
Okay.
what is going on. Okay,
Mm.
then you will see. But this is the step for reduction.
Mm.
Okay.
Okay, sir. Understood.
Okay. Then, if there is any question, it's us. Okay. So let us stop here. After 1 week.
Thank you,
Okay.
sir.
Okay. Thank you, everyone.
Thank you.
Thank you so much.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.
Good night. Bye bye.
Yes.